Welcome to Module 5, Lesson 2. So, we will continue to go into greater depth about fractions and how we can break them up. So, we'll be focusing on how I can specify and partition a whole into equal parts. So, let's define that for a second. A whole, in this case, is whatever we're currently talking about. So, if I'm talking about pizzas, a whole pizza is my whole. If I'm talking about a Snicker bar is my whole. If I'm talking about a breadstick, my breadstick is my whole. If I am talking about a gallon of milk, that gallon of milk is my whole. It's my whole gallon of milk. It's whole as in like the whole thing. It's my whole pie. It's my whole dinner. It's the entire thing. So just kind of keep that in mind. And equal parts, kind of going off the same idea that whenever we are doing any form of multiplication or division, they must be the same size. They have to be. That's kind of the main rule here. If they're not the same size, it does not work. We've been talking about that for a while. So, to kind of give an idea of this, I kind of want to show you how you can break things up or break a whole up into different pieces. Let's say I had a piece of paper right here. And in this piece of paper, I said, I am going to cut this piece of paper into 6 pieces. Well, that basically could be anything, but I'm specifically going to say they have to be equal pieces or equal parts. So parts is just a fancy word for pieces. So a fancy or an equal part or an equal piece. So for me, if I were just doing this myself, I would just cut this direction over and over and over and over. And once again, they need to be equal. And I'm going to do the best that I can with this. But once again, human error is the thing. If it's not perfect, for the purposes of this lesson, it's perfect. So, we will go ahead and, I know a little tricky trick here. Cut it in half and then do thirds on the side. And now we have 1, 2, 3, 4, 5, 6. Now, they definitely aren't 100% perfect, especially this bottom one right here. But for all terms and purposes, we are saying that every single one of these pieces is the exact same size. So this is 1, 2, 3, 4, 5, 6 equal parts to make one whole. So keep that in mind. But let's say I cut this up in a different way. And once again, for terms and purposes, this piece is right here, or this whole is the same size exactly as this one. So keep that in mind. I could, instead of cutting it this way, I could do it long ways. And go ahead and do that to the best of my ability. Once again, human error is a thing, but I will do it to the best of my ability without making a larger mistake. Ooh, my goodness, that was not a straight line. Without making a larger mistake than necessary. Cutting it like that. There you go. And now you have 1, 2, 3, 4, 5, 6 equal parts to make a whole. Now, my question is, once again, assuming that all these are the same exact size and all those are the exact same size as the ones next to it, is this piece the same size as that piece? If this piece of paper right here and this piece of paper is the exact same size, and I've cut these 6 pieces, and these 6 pieces are the exact same size as all the other 6, and these 6 are the same size to those 6, one strip from here would equal one strip of piece of paper from over here. It's kind of weird. I'll show you what I mean here in a little bit. But let's go ahead and do another one. Let's say I cut this up in yet another different way. Instead of doing it all the way across or all the way down, what if I did it in little blocks instead? Is that 6 equal pieces? Yeah. And once again, believe it or not, one of these is equal to one of these and is this equal to one of those as well. Now, I could do this even again, saying that this piece of paper is the exact same size as these other 3, and I could cut it this way. Now, Once again, human error is the thing. Unfortunately, I do not have the artist touch to such a point to make this exactly and perfectly to scale 100%. But in a mathematical world, if I did this perfectly, this piece right here, if I cut it in half, like this, took that little piece and stuck it underneath it, it would then look like that. And doesn't that piece look very similar to over here? It may, once again, may not be perfect, but you kind of get the idea here. And same thing goes with the rest of them. You can rearrange them in a minor way to make them equal to each other. It's going off that area idea, is that if the whole piece is cut up perfectly, this amount is this amount no matter what. You could have the area be 1 and 12 or 3 and 4. It's going back to the same idea, how a 1 by 12 is equal to a 3 by 4. They both have an area of 12. They look different, but they actually equal the same thing. So kind of going off that same idea. Now, I have a little piece of paper here to help illustrate my next point. This is one whole strip of piece of paper. It's one whole piece. So this is my whole. If I was talking about this card would be my whole, but I'm not talking about this one. Depending on what the problem's asking, your whole might be something else. Once again, like I said, it could be that pizza, it could be a candy bar, it could be a breadstick, it could be a piece of paper, it could be a classroom. You get the idea. So on here, I have made 12 equal lines. You can see these lines. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. Try to make sure you guys can see that. Equally spaced out lines. Now, 12. I'm going to flip this over now. How many pieces are there now? 1, 2, 3, 4. There's only 4 on this side. So the question is, which whole is bigger? Is this whole bigger with 4 pieces? Or is this bigger with 12 pieces? Which one's bigger? Or am I asking a potentially trick question here? And the question to that is, yes, I am. I am asking a trick question. Because on this, it goes to 12, right? It goes to 12. 1 through 12. But when I flip this over, am I changing the piece of paper at all? Am I changing how long this is, or how wide it is, or how thick it is? No, it's the same piece of paper. It's the exact same piece of paper. And that's what I'm getting at, is that your whole can be split up in different ways. You can split up this whole into 12 pieces, or you can split it up into 4 pieces. And, believe it or not, 4 out of 4, or 4/4, is equal to 12 over 12, or 12 twelfths. So what I'm saying is that if I had a hole right here, and I cut it up into 12 pieces, and I'm going to try to just do the mathematical ideology here. So 4 with 3 across like this, 4 by 3. And then scientifically, I am having the exact same piece right here, and I cut this only into 4 pieces. They actually equal each other. The holes are the same. It's just the same piece of paper, just cut up differently. So kind of keep that in mind. And, believe it or not, I'm actually going to redo this one just to kind of emulate this problem a little bit better. But I can actually make 12 out of an image like this. And let me show you what I mean by that. If I have 4 here, and now watch this. This might be a little hard to follow, so you might have to watch it a couple times. So I have 12 across here, right? If I turn it over, I have 4. Now, watch where this line is. Right here. This line right here. When I flip it over, there's a line there too. Right here. Right there. So, that's what I'm looking at. So, in one in one of these, 1/4, how many twelfths are in here? 1, 2, 3. So watch this. I'm going to cut each one of these into 3 equal pieces. Once again, going off the idea that I've done this perfectly and there's no human error at all. Hypothetically, we're speaking, they are all equal to the exact same size. Now, going off of that, how many pieces should I have here? Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which begs this question. I have 1/4 right here. How many twelfths do I need to fill in the exact same amount of space over here? Is 1 filling in the same amount? No. Is 2 filling in the same amount? No. Is 3 filling in the same amount? Yes. So here I would be able to be safe to say that 3/12. Remember, the 3 is how many I've shaded in, how many I'm talking about, so 3. And at the bottom, the denominator is how many total pieces it takes to make that whole. So down here it's 12. Over here, I have 1 filled in, and I have 1, 2, 3, 4 total pieces for my denominator. So, believe it or not, 3/12 is equal to 1/4. And I can actually prove it to you this as well. How many times does 3 go into 4? I just gave the answer. How many times does 3 go into 12? 3, 6, 9, 12. 4. So 3 goes into 3 how many times? 1 time. 3 goes into 12 how many times? 4 times. 1/4. So 1, 2, 3, 4. So it's the same thing. So this is where it gets very interesting, because now we are going down the realm, and we'll talk about this more in later episodes, but the idea that even though things are different sizes, different pieces, you can cut them up into little bits here and there, 12/12 is equal to 4/4. And this is actually a cool part. If I filled in all of this, if I filled in every single one of these squares, all of them, then I would have 12/12. How many times does 12 go into 12? 1 time. So I have 1 whole. How many, and I filled all of this in, I would have 4/4. Do I have a whole piece over here? Yes. Do I have a whole piece over there? Yes. Which means I can literally say that any number over itself is equal to any of these. So I can continue to say 6/6 is equal to 12/12, which is equal to 4/4, which is equal to 3/3. I could say 687 divided by 887. That's equal to all these as well. As long as they're all equal to the same size, those things are all equal to the exact same amount. And this is the important part, is that idea of the whole. Remember how in multiplication division, which we still are in the realm of that, every single part or every group has to be the same size. Same thing here. The whole. If I'm talking about a whole, it must be the same size for each of its whole. So I am not going to compare this piece of paper to this piece of paper. They're different sizes. They're not the same size. They wouldn't work. I'm not going to compare that to this piece of paper right here, because they're not the same size. In order to compare these things accordingly, you must have the wholes be the same size. Once again, if you're dealing with pizzas, if I have a 12-inch pizza, all of my other pizzas have to be 12-inch. I don't have a 12 and an 8-inch. They are all 12 inches. And this is important as well, is because this is 12, right? There's 12 pieces here, and there's 4 pieces there. So what's bigger? Is 1/12 bigger, or is 1/4 bigger? And this is where it gets a little interesting, because our brains have been trained to think a certain way. And there's nothing wrong with this. But our brains have been told to think the larger the number, the bigger the number. Which is true. 12 is bigger than 4, right? If I count, 4 comes first and 12 is later on. That is true. But if I am talking about a hole, and I cut a hole into 12 equal pieces, as I cut, if I'm going to have them all be the exact same size, if I am cutting this piece of paper into 12 pieces, are those pieces going to be very big? No. So the more number there is, the smaller the piece is. Well, over here, am I cutting this up a whole lot? No, I'm not. Which means each piece is larger. So this is where you have to think on this one. It might be tempting to say 1 over 12 is larger than the 1/4, but 1/4 is actually greater than 1/12 because, remember, this little strip right here, right there, is 1/12. This big block over here is 1/4. So let's say this. Let's say I'm assuming we all like chocolate here, so I'm going to say chocolate. Let's say I had 2 chocolate bars here. Would you rather have 1/12 of a chocolate bar or 1/4 of a chocolate bar? Which one's the bigger piece? Which one would you want more of? And if you like chocolate, you say 1/4. If you're like, I don't like chocolate, and if I'm going to have to eat it, then you might choose that one. But who doesn't like chocolate? Well, not everyone does, but you get what I'm getting at. Is that if you want the bigger piece, you want to go for the piece that's larger. 1 out of 4 pieces is greater than 1 out of 12 pieces. Remembering that the whole is the same. Once again, we'll go into this a little bit more as you need to. But more importantly, I also want to hit on this. As I mentioned before, how many of these are shaded? I have 3 here. So 3 out of what is shaded? I have 3 of the 12. So there are 12 equal parts, and 3 of those parts are shaded. Over here, I have 4 equal parts, and 1 part is shaded. So just kind of keep it in mind. Fractions, once again, are one of those math concepts that don't always click automatically, and that's okay. If you're like, I'm still confused, don't worry. We still got a lot we're going to be doing here. And biggest thing here, if you are struggling with doing this math, I highly recommend draw a picture. Draw a hole, draw a square, draw a box, and then cut it up into equal pieces. And that will help you, I promise. If it says 1 over 8, cut into 8 pieces and highlight one of those. So, yeah, just kind of letting you know. Hopefully this was helpful. Hope you guys learned something a little bit from here. And I hope you guys have a great day.